Hello, today we will be learning how to solve complex inequality using geometry. We will also be learning how to handle the nth roots of unity and its general solutions. And we will be doing this with the help of a CMI entrance problem. Before you move on to the problem itself, we first need to know a bit about the nth roots of unity. So let's do that. For any positive integer n, the nth roots of unity are the complex solutions to the equation x to the power n equals 1, and there are n solutions to this equation. The n solutions to this equation are also known as the roots of unity, and these are of the form e to the power I 2k pi upon n for every k greater than equal to 0 and less than n. So essentially we have the solutions of the form starting from e to the power 2k 2 pi by n times 0 e to the power I 2 pi by n times 1 e to the power I 2 pi by n times k minus 1. As you can see, these form the n roots of unity. Now this can also be represented in the standard a plus ib form as cos 2k pi upon n plus I sin 2k pi upon n. But for this problem, we will be referring to the exponential form only. Now, as we know, complex numbers can also be represented on the Argand plane. Here, the x-axis represents the real axis and the y-axis represents the complex axis. So, any number of the form a plus ib can be represented something like this, where this is at a distance a from the complex axis and a distance b from the real axis. This vector is represented as a plus ib. So similarly, a complex number in its exponential form as e to the power I theta is a vector of length 1 unit and at an angle theta in anti-clockwise direction from the real axis. So this vector is the vector representing e to the power I theta. Now, keeping this in mind, we come back to our nth roots of unity. Now, the nth roots of unity can also be represented on the Argand plane. Here, they lie on a unit circle, that is, a circle of radius 1, at uniform intervals of angles, that is 2 pi by n. For example, we are considering for n equals 3. Now notice, this is a unit circle on the Argand plane. Here we have marked 3 vectors. This is the first vector, this is the second vector, and this is the third vector. Now, each of these vectors are of the form e to the power of I 2 pi by 3 times k. Now, this vector is equal to 1 for k equals 0. As you can see, 1 is just e to the power I 2 pi by 3 times 0. And this vector is for k equals 1, that is e to the power I 2 pi by 3 times 1. And as you can notice, this angle is also 2 pi by 3. And the third and the last vector is e to the power I 2 pi by 3 times 2. And this is corresponding to k equals 2. And as you can see, each of these vectors have a uniform angle of 2 pi by 3 between them. And the first vector, that is vector 1, is at angle 0 degrees. and the second is at angle 2 pi by 3 degrees from the real axis, and the third is at an angle 2 pi by 3 times 2, that is 4 pi by 3 from the real axis, and these three form the cube root of unity. Now, a root of unity on the unit circle occurs after every 2 pi by n angle. So now we move on to our problem. So today we are going to do a 2019 CMI entrance problem. This problem asks us to count the number of roots omega of the equation z to the power 2019 minus 1 equals 0 over complex numbers that satisfy this inequality, that is, mod of omega plus 1 is greater than equal to square root of 2 plus root 2. First, let's focus on the inequality and try looking at things geometrically. At times, looking at things geometrically helps give more insight into the problem than the bare equation itself. Now, coming back to the problem itself, we have been asked for this inequality, that is, mod of omega plus 1 greater than equal to square root of 2 plus root 2. So let's first translate this into words. This essentially is asking for all those omegas which are at a distance of greater than root 2 plus root 2 का square root from minus 1. So we can obtain this by rewriting this inequality as omega minus 1 mod is greater than equal to square root of 2 plus root 2. So it's essentially asking for all those points which are at a distance of greater than 2 plus root 2 from minus 1. And the problem itself is asking all those points which also satisfy this given equation z plus 2019 minus 1 equals 0. Now, we first look at the diagram. Now, as we can see, this is the Argand plane and this is the point minus 1. Now, we want to find all the points which are at a distance of greater than square root of 2 plus root 2 from minus 1. Now, how do we do that? First, we find all the points which are at a distance equal to square root of 2 plus root 2, and that will give us a circle of radius square root of 2 plus root 2. So this is actually a circle of radius square root of 2 plus root 2, and all the points which lie outside this circle in this region will satisfy this given inequality. Now that we have some information regarding the inequality, we come back to the actual problem itself. So we instead focus on the equation now. So let's do that. So now we return to the problem. Now let's focus on this equation which was given to us, that is x to the power 2019 minus 1 equals 0. This translates into the equation x to the power 2019 equals to 1, and this gives us the 2019 roots of unity as its solution. Now, the 2019 roots of unity, how do they look like? Yes, you're right. They look like e to the power I 2 pi by 2019 times k, where k varies from 0 till 2018. These form all the 2019 roots of unity. Now, we want to find all the roots of this equation x to the power 2019 equals 1 which satisfy the given inequality. Again, we make use of the Argand plane and draw out our solutions. So first, let's draw out all the solutions to the unity. They will lie on the unit circle like this. As you can see, this is a unit circle on the Argand plane, and all the roots of this equation x to the power 2019 equals 1 have to lie on this unit circle, and they are at a uniform angle of 2 pi by 2019 away from each other. Now, we also draw the relevant diagram for our inequality. So let's do that. Now, as you can see, this yellow circle actually represents the unit circle, and all the roots of the unity of the equation to x to the power 2019 equals 1 lie on this unit circle. Now, what is this red circle that I've drawn? Remember the inequality? Yes, the inequality omega plus 1 greater than equal to square root of 2 plus root 2. This red circle helps us identify that inequality. Now remember, this yellow circle is actually a unit circle centered at 0. So this point is 1 and the left point is minus 1, and as we remember, this inequality was actually represented as all those points lying outside this red circle, which is a circle of radius square root of 2 plus root 2 centered at minus 1. So let's highlight the relevant region. So all those points lying in this green region will actually be the solution to this inequality. But what we actually need is all the roots of the equation x to the power 2019 minus 1 satisfying this inequality, and as we know, those roots actually lie on this yellow circle. So we need to make use of the properties of circles and triangles to actually trace out this angle, that is this angle. So as you can see, this green region actually takes this chunk of the bigger circle. So we need to find how many roots of unity or of this equation actually lie in this arc, and in order to find that, we need to find this enclosed angle. And how do we do that? Yes, you guessed it right. We make use of the cosine rule to find the unknown angles. How do we do that? First, we find this angle theta, and we can find that very easily. How? Notice that this is the radius of the red circle. So that means the length of this line segment is actually square root of 2 plus root 2. And remember, these are the radius of this unit circle. So these are of length 1. Now let's focus on this particular triangle. Let me magnify that and draw that again. So we have a triangle like this. One side has length 2 plus root 2 and the other two have length 1. And we need to find this enclosed angle. And we can do that very easily using the cosine rule. As we know that using cosine rule, square root of 2 plus root 2 whole squared is actually 1 squared plus 1 squared minus 2 times 1 times 1 times cosine theta. That implies 2 plus root 2 is equal to 2 minus 2 cos theta. That implies cos theta is equal to minus 1 upon root 2. So now in order to find this angle precisely, we need to look at the diagram carefully. Now, some of you might have this question as to why this particular circle intersects this unit circle at these points. That is, it could also have happened that this could have overshot this unit circle. But remember, square root of 2 plus root 2 is actually greater than 1 but less than 2. So that means this particular radius will be less than 2 and hence inside this, and since this is greater than 1, it will be to the right of the y-axis, and hence this particular angle will actually be greater than 90 but less than 180. So we concluded that our theta has to lie between 90 and 180. So which angle lying between 90 and 180 gives a cosine of minus 1 upon root 2? And that's pretty easy to see. The only angle that does that is theta equals 135 degrees. That is 3 pi by 4. And if our theta, which is this angle, is 3 pi by 4, what is this angle? Yes, you're right, it's just pi minus 3 pi by 4. That is pi by 4 or 45 degrees. And now by symmetry we can also say that this angle is also pi by 4. So what did we conclude? We concluded that all those roots of unity which make an angle less than pi by 4 with the real axis, either positive or negative, will satisfy this inequality. So let's write that down. So all the roots of unity are of this form: e to the power I 2 pi by 2019 times k. And we recently concluded that this angle 2 pi by 2019 times k is actually less than equal to pi by 4. As explained before, because these points have to lie in this arc to satisfy our given inequality. So what does that give us? That actually gives us that k, being an integer, has to be less than equal to 252. Now that means k can be all the values starting from minus 252 going till 0 till plus 252. And how many numbers are those? They are just 252 times 2 plus 1, that is 505 numbers. So we found that all the k such that mod k is less than 252 e to the power I 2 pi by 2019 times k will satisfy our inequality, that is omega plus 1 less than equal to square root of greater than equal to square root of 2 plus root 2. And since these are also the solutions to x to the power of 2019 minus 1 equals to 0, these are all the possible solutions. So our question, if you remember, was asking for the number of solutions. So our answer is precisely 505. So that's all for this video. Hope you enjoyed this. See you next time.